All right, today's lesson, Unit 17, Unit 4, Lesson 17 is on binomial distribution. So binomial distributions, there's going to be two different ways to do these. You can do it by formula, which I'll show at the bottom of the first page of notes here, and then you'll still use a calculator for it, but it's a formula, or there's some menus in your calculator that you'll be able to use. So basically, a binomial probability question has two outcomes to it, by meaning two, such as success and failure, or true and false, or this and not this. Or you have to be able to change it to two outcomes. So for instance, like if you roll a die, you could say, what's the probability of getting 4 and not getting a 4? So as long as you can put it into two distinct probabilities of this and not this, you can do binomial probabilities. So formula, if you want to do it by hand, and most of you will not want to do it by hand, and I would probably suggest to not do it by hand in most cases, because I'll show you with the second example. But here's the formula for this. You're going to do a combination at the beginning, with n being your number of choices and r being the number of things that you're picking. You'll have a probability of success and a probability of failure. So here's what this looks like. A survey found that 1 in 5 Americans say he or she has visited a doctor in any given month. So 20%, 1 out of 5. If 10 people are selected at random, find the probability that exactly 3 will have visited a doctor in the last month. Okay, so 10 is going to be our n. Oops, didn't work. 3 is going to be the r. P is going to be 20%, and Q is going to be 80%. So by the formula there, you would do 10C3.2 to the third, because that's R, and then that's a 3, 0.8, then because there's 10 total, so then 10 minus 3, so that would be to the 7th. And you put that in your calculator, and you're going to get I'll just type it in real quick just so you can see it. So 10 math probability. Remember, we did combinations last chapter. 10C3 times 0.2 to the third times 0.8 to the 7th. Oh, I messed that up. Sorry. Let me do that again. I wasn't paying attention. 10C3. See, I just showed you what you shouldn't do. 0.2 to the third, get out of that, times 0.8 to the 7th. That looks a little better. Okay, 20.1%. So we're going to write these as percentages, 1 decimal place after that. Okay. Now, here's the problem that you'll come across with using the formula. Survey from this research found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them. So that means you'd have to account for 3, 4, and 5. So you'd have to do this formula 3 times and then add them together. And that becomes a bit of a pain. So, what it's going to start to look like here, you'd have 5C3 times 0.3 to the third times 0.7 squared, and then you'd have to do it for 4. And then you'd have to do it for 5. Now, it's not real terrible on this one. Plugging that in gets a little bit, whatever. You get if you do it, you get 16.3%, by the way. I just think that's probably a little more work than it's worth. I mean, this is 3, 4, and 5. What if it was, there were 17 things to choose from and you wanted at least 9? Then you'd have to do 9 and 10, 11, 12, 13, 14, 15, 16, 17. You have to add all those together, and that's way, way, way too long. Okay. Nonetheless, this is how you would do it. If you like the formula, use it. If you don't, then that's where this is going to come into play. So there's a menu in your calculator, which I will show you here in a second, um, that uses binomial. Now there's two different binomial buttons. So on your calculator, so if you do second and vars, okay, second here, vars right next to the clear button, and you arrow down or up. I'm going to arrow up just because it's a little faster. You have these binomial PDF and CDF. Notice how almost all the formulas are CDF, except for the one, which is exactly. So if I want to, like the first example right here, when I was doing this, I'm doing exactly 3. So I would have used this formula. Whereas when I'm going more than, less than, at least, that type of stuff, you're going to be using one of these formulas, all of them ending in CDF. So PDF does one number and CDF does a group of numbers, is essentially what happens. Okay. So what you have to do is just match it up, and then the N, the P, and the X are the same thing that they were in the previous. I guess we used R in that one. R and X mean the same thing. So N is the total number. N is total. P is probability as a decimal, and X is how many you're picking out of that. Okay, let me show you how it works. Public opinion reported that 5% of Americans are afraid of being alone in the house at night. There's your P. If a random sample of 20 Americans is selected, there's your N. Find these probabilities. There are exactly 5. So you would do binomial PDF. I'm going to use this formula right here for exactly. So my total, which is 20, my percent, which is 5%, so 0.05. Make sure you put 0.05, not 0.5, and then exactly 5. So on the calculator, and I'm going to assume that you have one of the newer calculators that will put a menu like this. If you don't, ask me and I'll show you. So you put 20 there, put 0.05 there, and 5. And click on paste. It's going to pop that thing up right there, which is how you would type it in if you don't have that menu, by the way. The comma, if you need it, it's above the 7. Again, I can show that to you if you need me to. And you hit enter, and it gives you the number that goes along with that. So you have less than a 1% chance. So it'd be 0.2% chance of that happening. All right, there are at most 3 people. So then I would go through the list here, find at most. Here it is right here. So I would do binomial CDF. And I do want you to, so you can either write the whole word out or put the B and then PDF or CDF, whichever one is the appropriate one. That's a good enough shortcut for me. Don't just put PDF and CDF, because in the next chapter we're going to do normal distributions, and that's using this stuff too. So I want to put a distinction between them. So make sure you put the B in the front. Okay, sorry. So then you'd have 20.05 and then X, so 3. So second bars, binomial CDF this time, 20.05, 3. Okay, so when this is doing at most, this would be doing 3, 2, 1, or 0 is what that would account for. All right, so 98.4%. And then the last one, there are at least. So here's the at least. So we're going to follow along with that formula. So that's 1 minus binomial CDF 20.05. And then it says to do X minus 1. Oops, that should have been there. That should be a comma. Let me erase that, sorry. And then 3 minus 1, so 2. If you want to write it as literally write 3 minus 1 in there, that's fine. So then you type this one in as 1 minus second bars CDF 23 and then change that to a 2. So 7.5%. So that's how you would use the menu in your calculator. So again, second in vars to get into that spot. Make sure you're choosing the correct one, PDF or CDF. Follow along with the formulas. All right, and then the last thing, mean and standard deviation for a binomial distribution. These can only be used in a binomial distribution. This does not apply to other things that we're doing. So a coin is tossed 4 times. Find the mean and standard deviation of the number of heads that will occur. So it'd be heads and not heads. So you could do that as binomial. So for the mean, number of times you're flipping it is 4. Probability of getting heads would be 50%. So 2, which should make sense. You toss a coin 4 times, you would expect to, the average to be 2 heads. Standard deviation is the square root of 4 times 0.5, and then Q would be 0.5 as well, because those two things total up to 100%. So square root 4 times 0.5 times 0.5 gives you 1. Okay. Die is rolled 500 times. Find the mean and standard deviation for the number of 6s. So you get a 6 or you don't get a 6. Probability of getting a 6 is 1 out of 6, since there's 6 sides on a die. 500 times 1 divided by 6 will give you 83.3. And then the standard deviation, square root 500 times 1/6 times 5/6. Square root 500 times 1/6 times 5/6. So 8.3. All right, and that is lesson 17. Let me know if you have any questions.